Okay, someone is going to help with number 11, and we will see who that is. We have a whole fresh slate of people, but everybody's not here.
Yeah, she does.
We got, it's going to be Rindy.
Oh.
That's the luck, bro.
Yeah, Rindy.
Yeah.
Got a lot.
Maybe just got a way.
You had to set a new fresh wheel ground. Okay, go ahead, Rindy. What do we do on this one?
Okay, I was trying to get in the front of the page now, so I didn't get second.
Oh, you didn't?
No, I didn't get to. So she doesn't have her paper today, she had to
Oh,
start
okay.
from.
Well, Rindy, then what you're going to do is you're going to tell me what to do here on this one. You are just looking at this and you will tell me what to do.
All right. Well, you need to factor the first one. And
Like
so
this
it
here?
looks like it would be -5 and +3.
So equals, what's that going to be?
-5, x minus 5, and x plus 3.
So working.
And then
So what's
multiply
your
everything by
what's
that.
your least common denominator going to be?
X minus 5x plus 2.
Okay, and you have excluded values out of this?
Yes, -3 and +5.
Good job, Randy.
So we have x equals, you say, -3 and 5?
Yes. Or x is not equal to.
X is not equal to, thank you.
Go start this.
Okay, and so you said just go ahead and multiply through by this.
Next week? This week.
I'm going to go to the skinny pen here because I know that writing could be an issue here. So we got x minus 5. Is this how you, does this look right?
Yes. Yes.
And you said multiply through by this
Least common.
by least common denominator. Okay.
Aaron? Sweet. You probably keep
He had a roll going. He was actually coming to school for a little bit.
So minus
3 days. All right.
6 over x plus 3.
Yeah, you were the only reason.
Then you have x minus 5.
He found out I had a boyfriend, so.
Yeah, you just look at it.
I told him no.
Broke my heart. Everyone started, everyone started.
Yeah, you
Money.
were really.
Okay, can we just can we take it easy on the non subject chit chat?
Yo. Yeah, come on. Cut it out.
Over here on this side of the classroom.
The males.
It's happening.
It's not just the males. All right, go ahead, Rindy.
And then the
She probably is, man.
x minus 5s cancel out.
Okay, like right here.
Yes, on the first one, and then also the x minus, or the x plus 3.
Okay,
And then on the second one, both of the x plus 3's cancel out.
okay,
And then on the last one, x minus 5 cancels out.
okay.
And so you have
No, sweet.
56 minus 6x plus 30.
That's 6x. So you distributed it
Yes.
here. How'd you get plus 30?
It's 5 times.
It's 5
Oh,
times-
minus minus. Okay, that's how you got it. Okay, good. It's gonna be-
And then equals 7x plus 21.
All right.
21.
And then you would, let's see, you get, is that like 86?
Yes.
Okay, so we get -6x plus 86 equal 7x plus 21. So really now it's just a problem. So we
And
get
then,
plus 6x.
yes.
Yeah.
I have a question. So
Yeah.
I know how to solve it, and
But I just don't understand how you can put like an X minus 5 on top and not have to put it on the bottom as well. Like,
Yeah, okay, what we're doing, and I think what you're doing, let me go ahead and finish solving this and then answer that question. So I'm gonna block, because that's actually a good question. So now what we've done is we've did a double cancellation here. So we have is, that's gonna be, what is that, 65?
yeah.
So 65 equals 13x. And so we have, divide by that, we get x is equal to 5. Okay. And x equals 5 is what? A what? An excluded value, right? Okay, since x equals 5 is an excluded value, x equals 5 is a what? Is an extraneous solution.
Solution extraneous.
And what I'm going to do is I'm going to come back to Chloe's question here on this. To me, I don't know, Chloe, that was a good question. And the question is that when you multiply the numerator by the certain thing, why did you not multiply the denominator by the same thing? Well, the short answer is that we're trying to clear out the denominator, so we don't want to multiply more stuff in the denominator. And you see that when we multiply by the least common denominator, we multiplied both sides of the equation by the same thing. And so we're keeping the integrity of the equal sign. Now, when you're talking about a fraction, you're trying to get a common denominator for the purpose of adding or subtracting fractions. And so the process of getting a common denominator, you're looking at the equality between the numerator and the denominator, essentially, doing the same thing on each to get a common denominator. But this thing right here is a different operation. So what you're doing is you're thinking back on section, I think it was, 10.1. If you look through the papers, if you keep your papers, you'll see that. So that's the best thing I can think of. But I'll tell you one thing that, to me, that it's an important question, because sometimes when I start working on these problems and I'm not thinking, I'm not really paying attention very well, I'll do that. I'll multiply the numerator and denominator by the same thing. So it's a matter of just being intentional, remembering what it is, and working with that.
Yeah, they have Starbucks pictures. We did have Starbucks. Yeah.
Can I get a stone?
I'm gonna have a stone. I hooked up a lot yesterday. Now you can start. Right?
Molly doesn't know.
Because I do
This is
this
yours.
Okay, good.
Wound up exiting?
Let's go to number 12. So, to me, see, Randy worked that out just like live in classroom, right? That was pretty good.
Yeah.
Pretty good, that was really
He
good.
did do that.
Maybe old.
I gotta make sure. Okay, on to number 12. Are you working number 12? I hope.
Yup. Yup. Putting my crackers in.
Let's see how you're doing. And while you're working number 12, I want to hand out the next thing we're going to be working on, because this if I can find it, I will find it.
So. Huh?
You're finished.
Do you guys study on the x squared?
The X squared.
Me too.
Plus 4. Plus 4.
I have 11x minus 24. And the x squared.
What'd you have?
29.
What'd you get 38?
That's a line, maybe.
5 times 7 is 35.
That's right.
What you do is, okay, so if you.
Okay, but I was doing right.
Remember how we used to do that? Oh, yeah, and then you could bring up more back to, like, back to this, what's it back?
It's up in this one, yes, but
This one.
it's a lot.
Okay. Let's choose someone
She's a big one.
someone else here.
Mark.
Let me get here, we got,
Bill, but I'm stuck. Bill,
there we go. Yeah, I hear people being stuck a little bit here, we'll get through it,
Bill.
Don't worry about
it.
it'll be okay. It looks like we got
Yeah, I don't beat.
Chloe.
Yay.
Chloe.
Cleo.
It almost ticked over to Siggy, but it was Chloe, all right.
Cleo.
What was it?
It almost got to you, it's going close to your name, but it stopped at yours, all right. What do we got here?
I factored that, whatever it's called, and I got x minus 7, x plus 3.
It's 10x plus 21,
Good one.
and equals like this. And but before we go on here,
X minus 3.
x minus 3, so x minus 7, x minus 3. Okay, can you tell, just by looking at the problem, when you factored that and saw that, can you see how that's helpful?
Yes.
That's a fortunate factoring. Okay, let's go ahead.
That's also the least common denominator.
So LCD is going to be equal to x minus 7, x minus 3, okay?
And then the excluded values are 7.
That's disgusting.
Here.
So x cannot equal, you said 3 and 7?
Yes.
7, please.
Now, the thing about it is this is really kind of a fine point. What happens is, just convention has, when you do set notation, this conventional standard is to put them in the order from least to greatest. It doesn't have to be like, it's just sort of a more conventional way of doing things. Does that make sense? That's all. Go ahead, Chloe.
And then, so I did find a way to factor out x squared minus 29, so I just left it as is.
Okay, all right. So you have x squared minus 29, like this,
Times
over, you got x minus 7, x minus 3,
Yep, and then after the top, I multiply it.
x minus 7, x minus 3.
Teachers, and pardon the interruption, just a quick announcement. Those teachers that are testing at this time, we understand that we are facing some difficulties with the internet and just the whole process of testing. What we recommend at this time, till we get more TEA information, is just to take a break. I would not log on, try to continue testing. I would get off your computer, and we will get more direction from TEA, and we will try to correct this. So at this time, we're on the holding pattern. If you would like to take your kids outside for a little walk, catch a little fresh air, please do so. But we will try to resume testing as soon as possible. So those will remain off, and we'll let you know as needed. Thank you, teachers.
And then I canceled out whatever it was.
You canceled out whatever you could, okay, like this, and this here, like that.
Yep. Do that like that.
This one like this, okay.
Yep. And then I got the x squared minus 29 equals 6. X minus, here, minus something.
18 plus 5x minus 35.
And then I combined like terms or whatever it's called, and then I got x squared minus 29 equals negative 53 plus x, or 11x.
Equals x equals negative 59,
Or I got 53.
negative 53
Plus 11x.
plus 11x, okay.
And then I added 53 to the other side.
So you took, let me just put over here, so add 53 plus 53
Yep,
and minus 11x,
I guess.
so plus 53 minus 11x. So these go away, right? So what do we have left here? We got x squared and minus 11x
Plus 24.
plus 24
Equals 0.
equals 0. Okay. So 0 is going to be equal to, what is that going to be? We have minus
5
1.
and 6.
Yeah.
No.
Square minus 29.
8 and, yeah, 3 and 8.
8 and 3. 8 and 3. So we have, so what is x equal to? X is equal to
8.
8.
X is equal to 3.
X is equal to 3. And real solutions?
Yes, or 8 is the real solution, the extraneous is excluded, right?
So x equals 8, real solution. X equals 3, extraneous solution, right? Is that what you meant? Okay, so that's going to be it, right?
Right.
All right, thank you. Okay, I want you to do number 13 on the subsequent page there. And this other one, you can turn that in. I wanted to get through 14 today, but I think we can probably just kind of run a little bit more. See if we can get to 13.
What do you want, 13? 13. You holding on to it? At my file.
Yeah, let me finish it.
Okay.
Long foot is not signed.
Maybe she'll finish hers. Or maybe she'll find her other one and just stay with
Oh, well.
Maybe the other one.
Probably, hopefully. Or
If I
hopefully.
find it at home, I'll bring it.
Yeah. Thanks, Siggy. Lexi, here's this. Now, if you look at the paper I handed out, 13 and 14 are similar to the ones we've been doing, but then after you get to 14, you're looking at the real-world problems, which, the story problems, which, what was that, Hell's Library, or Satan's Library, whatever it is, remember I showed you that?
No.
I didn't show you that?
Yes, you did.
I'll show you Satan's Library, I showed you that. Hell's Library, you don't remember that?
They're probably at you.
That's where Addie lives.
Okay, yeah, I'll show you that.
What is it?
Here, show them real quick.
I got 6, F plus 3,
But,
You watch a ball.
See?
but it is, problems 15 on are really, Marcus, really problems 15 on are related to what Marcus was talking about yesterday. And he asked the question, what is the real world use of these things? And you're going to see some of those problems like are legitimate real world problems if you look at those. So like there's an ice skating rink dimension problem if you have the area. There's one where you have a boat going up and down a river against a current and with a current. So those are some real world uses of that. Okay, so, and there's the batting average problem, like how many hits in a row do you need to get your batting average up. So I guess our cheerleader girls were missing this one here. See, this is Hell's Library, and here's the library right here. Here's the caretaker, and all these things are a big book of story problems, more story problems galore.
That's pretty funny. I don't get it.
You don't get it, Mark, it's D right here.
Huh? You get it?
Like, store problems.
Oh. No, there's stomach.
Okay,
That's me, hard.
number 13.
It's hard.
Okay, here we go. We got
Stop. It's gonna be,
we're gonna get
kind of,
Siggy or Lexi, Siggy or Lexi, Siggy or Lexi. It's Siggy.
got it.
All right, Siggy, what do you got?
It's gonna be good.
I think it's,
Ready to X for 3.
yeah, the first one I think is gonna be 2 times X for 6.
3.
Alright, so 3 is plus 3.
So 2x plus 6 equals that. And so what's your common denominator gonna be, or LCD gonna be?
Yeah, that, two, x plus 3, and time. Be x plus 3.
Well, you need to worry about the 6 too. You have 6, you have x plus 3, and what else do you need?
X plus 4.
X plus 4.
Yeah, where's the 2? The 2 don't matter. You multiply that, it doesn't matter. You multiply, it's gonna be 12.
See, 2 is included within the 6.
Yeah, I see.
The 6 will get rid of the 2. So we have,
Yeah.
so we have 5 times 2, x plus 3. And what, we have to multiply through by this common denominator, right?
X plus 4, yeah.
X plus 3,
There you go.
x plus 4.
Uh-huh.
And then we have minus 1, 6. We multiply that by 6, x plus 3,
Yeah.
x plus 4. And then on the other side, we have 2 over x plus 4
X plus 4.
times 6, x plus 3.
What?
You don't get it? You don't
Where are
get it?
you getting 6? 6 because of the,
The 2, because of 2.
No, 'cause it's 6.
Oh, there's the 2, excuse, no, that's right. That's all right, isn't it? That's the 1. Okay, what do we cancel out here?
Because of the 2, Alex.
but
She don't know.
where did the 2 go with it?
X plus 3, x plus 3, right?
Yeah. Yeah.
And then
6.
6 over 6, and then that, right?
Cancel out. There you go.
So we have, right here, we have 30 divided by 2, which is 15,
Yeah.
x plus 4.
Uh-huh.
And then we have minus x plus 3,
X plus 4.
x plus 4. And equals on the right side, we have
12.
12, x plus 3.
There you go.
And then if we go ahead, and so we have 15x plus 60, and over here we have minus x squared, minus 7x,
Mm-hmm.
minus 12,
Mm-hmm.
and on the right side we have 12x plus 36. So it's really solving a quadratic equation,
There you go.
and probably you want to get all these x squared stuff on the other. You can just leave it all negative and multiply, but I would just get everything on the right side.
Yeah.
So here you have negative x squared, you have plus 8x,
8x.
and then you have plus 48,
52.
and it equals 12x
Yeah.
plus 36.
Uh-huh.
So you just add all this stuff on the right or subtract. So plus x squared minus 8x minus 48. That's supposed to be 36.
Yep. There you go.
So we have here is that'll cancel out, right?
Mm-hmm.
So you got 0 is equal to, you get x squared, and you have, that's going to be 4x, isn't it?
Yep. Yeah, 4x.
And then
Negative.
minus 12.
12. Yeah.
So 0 equals, what's that going to be? XX, you have a minus plus,
It's gonna be x. It's gonna be minus 2 plus 6.
minus 2 plus 6.
Yeah. There you go.
So you get x equals 2,
Uh-huh.
x equals negative 6,
Exactly.
and which one is are those excluded values?
Yes, sir.
No, they're not, okay. So real solutions.
Yeah, the real solution.
I'll give you a start. You got, Siggy, you got your paper, Siggy? When you go to class.
You don't need this one.
You got your paper?
Yeah, I have it in my bag.
Okay.
Every time.
All right.